Welcome to our deep dive today.
Yeah,
We're going to be taking a look at your payment system code and how it uses object-oriented design,
that's right.
or OD for short.
Yeah,
Um, you know how like some things in technology just work seamlessly?
right.
Click pay and boom, transaction done.
Exactly.
But good design is often invisible.
It is.
And today we're going to be peeling back that layer to see how elegant OD can be when it's done well.
Absolutely.
And this will help you understand how software is structured for things like flexibility and security
Right.
and maintainability.
Yeah, and you know what's really cool about this is that you don't even need to be a programmer to appreciate these concepts.
Right.
We're going to break down complex ideas into relatable examples.
Yes.
So you can see how these principles actually shape the software that you use every single day.
Okay, cool. So let's unpack this a little bit.
Okay.
So OD is all about organizing code into reusable modules
Right.
called objects
Yeah.
to create well-structured software. So what are the key advantages of this approach?
Well, imagine building a house.
Okay.
Would you just start laying bricks randomly?
No.
Or would you want to have some kind of blueprint?
Right. A plan.
OD is like that blueprint for software. It
Okay.
makes the code much easier to understand,
Right.
to modify, and to extend, which is really essential when you're creating these robust and maintainable systems.
Right. It helps make sure everything fits together properly.
Exactly. And within OD, there are 5 key principles.
Okay.
We have inheritance,
Okay.
polymorphism,
All right.
abstraction, encapsulation, and composition.
Gotcha.
We're going to explore each of these using your payment system as a real-world example.
Cool. Let's start with inheritance.
Okay.
Looking at your code, I see a base payment processor
Right.
and then specialized types like UPI, debit card, and so on.
Yeah.
It's kind of like a family tree where each payment type inherits traits from the parent.
That's a great observation. The payment processor sets kind of the general rules for how payments work.
Okay.
Each specific type, like UPI or debit card, inherits these core rules,
Right.
but then adds its own unique twist,
Okay.
like specific security protocols or processing steps.
Gotcha.
Inheritance helps us avoid redundant code
Uh,
and ensures consistency across all the different payment methods.
so they all follow the same basic structure,
Right.
but each has its own specific way of doing things.
Precisely. It's like having a family recipe
Okay.
that everyone starts with,
Right.
but then adds their own personal touch to
Yeah.
create different variations.
I like that analogy.
Yeah,
Makes it much easier to understand.
good.
Okay, now let's move on to polymorphism.
Okay.
This one's always sounded a bit mysterious to me.
Yeah, it's a cool word.
Is it really as magical as it sounds?
Well, it does have an element of elegance to it.
Okay.
Think about how you use a payment system.
Right.
Ideally, you shouldn't have to worry about whether you're using UPI or a credit card or any other method.
Right. You just want to click pay and have it work.
Exactly.
Yes, absolutely. The simpler, the better.
Right.
Especially when it comes to payments.
That's exactly what polymorphism achieves.
Okay.
It allows you to use a single interface,
Okay.
like a process payment button.
Right.
Regardless of the payment method,
Mm-hmm.
behind the scenes, the system knows how to handle each type specifically.
So it's like having a universal remote
Yes.
that can control different devices with the same buttons.
Exactly. And if we look at your code, we see this in the payment service class,
Okay.
which seamlessly handles all these different payment types
Right.
without needing to know the specific details of each method.
This is really making me appreciate the thought that goes into designing good software.
Well, good design often goes unnoticed
Yeah.
because it just works.
Right.
But there's a lot of complexity under the hood,
Yeah.
which brings us to our next principle, abstraction.
Okay. Abstraction, trying to explain this one always makes me think about driving a car. You don't need to understand the engine to drive.
Right? That's a perfect analogy.
Yeah.
Abstraction is about hiding the complex details behind a simpler interface.
Right.
So you can interact with the system
Okay.
without being overwhelmed by all the mechanics underneath.
It's like the dashboard of the car.
Exactly.
It gives you the essential controls without you needing a degree in mechanical engineering.
Precisely in your code, the payment processor class is abstract.
Okay.
It defines the process payment method,
Uh-huh.
but it doesn't specify how it's done.
Right.
That's left to the specific payment types.
This is reminding me of that saying, ignorance is bliss, but in a good way.
Yes. Sometimes it's better to focus on the what rather than the how.
Okay, now how about encapsulation?
Okay.
This sounds like it has something to do with security.
You're on the right track.
Okay.
Think about your personal information like your name
Uh-huh.
email address,
Yeah,
etc. When you use a payment system, this data needs to be protected, right?
absolutely.
Yeah.
It's scary to think about what could happen if that information fell into the wrong hands.
Encapsulation is like putting that sensitive data in a vault.
Okay.
You can access it through controlled methods,
Okay.
but not directly.
Ah.
This prevents accidental changes or misuse.
So it's not just about hiding complexity, it's about creating a security barrier.
Exactly. And if we look at the user profile class in your code,
Okay.
we can see how it uses getters and setters
Right.
to control access to the user's data,
Yeah.
ensuring its integrity and security.
This is making me realize how much thought goes into designing even seemingly simple classes.
Every detail matters
Yeah.
when it comes to building secure and reliable software.
We've covered inheritance, polymorphism, abstraction, and encapsulation.
We have.
What about that last principle, composition?
Composition.
Yeah.
Let's say you wanted to add a new payment method to your system,
Right.
like cryptocurrency, which is becoming increasingly popular.
Yeah.
How would you approach that?
Well, I imagine you'd need to create a new class for the cryptocurrency payment type,
Right.
but you wouldn't want to break the existing structure of your system.
That's where composition shines.
Okay.
It's about creating these flexible relationships between objects.
Right.
Instead of forcing everything into a rigid hierarchy,
Mhm.
we can combine objects in more modular ways.
Okay.
For example, the payment service class has a payment processor.
Okay.
We can easily swap out different payment processors without changing the overall structure of the service.
So it's like building with Lego blocks.
Yeah.
You can add or remove components without affecting the stability of the whole structure.
A perfect analogy.
Yeah.
This modular approach makes it easier to add new features,
Right.
adapt to changing requirements,
Uh-huh.
and reduce the risk of breaking existing code when making changes.
This is fascinating.
Mm.
I'm starting to see how all these principles work together to build a well-structured and flexible system.
It's like a symphony orchestra,
Okay.
where each instrument plays its part.
Right. To create this harmonious whole.
I love that. Okay, so we've covered the 5 core principles of O.
Yeah.
Can we now dive into the actual code
Absolutely.
and see how these principles are implemented in your payment system?
Let's take a closer look
Yeah,
and see how the code reflects these elegant design concepts.
awesome. Let's do it.
Right.
All right, so we've got a good grasp of the theory behind OOD. Now I'm curious to see how it all plays out in the actual code. Where do we start?
Let's begin with the user profile class.
Okay.
This is where the encapsulation principle really shines. Remember how we talked about protecting sensitive user data?
Right, it's like a digital vault for user information. What makes it so secure?
Notice how the name and email fields are marked as private.
Okay.
This means they can't be accessed directly from outside the class.
Right. So if another part of the program needs to access the user's name,
Yeah?
it can't just peek inside the user profile class.
Exactly. Instead, it has to go through specific public methods called getters and setters.
In this case, we have getName and setName methods,
Right?
which act as controlled entry points for accessing or modifying the user's name.
So it's not just about hiding complexity, it's also about protecting sensitive data.
Precisely by controlling access to these fields.
Yeah.
We ensure data integrity and prevent accidental or malicious changes that could compromise the user's information.
This is giving me a whole new perspective on how much thought goes into designing even seemingly simple classes. Every detail has a purpose.
Absolutely. Now let's shift our focus to the heart of your payment system,
Okay.
the payment processor class.
Right.
You might notice it's marked as abstract.
Right. I remember you mentioning that abstract classes can't be directly instantiated.
Yeah.
They act more like a template or a blueprint for other classes.
Exactly. In this scenario, the payment processor class defines the common structure and behavior for all payment types,
Okay.
but doesn't dictate the specific implementation details. It's like providing a general framework for processing a payment.
Right.
But the specific steps are left to its subclasses.
That's a clever way to ensure consistency while allowing flexibility. Each payment type can inherit the core functionality,
Right.
but still maintain its own unique processing logic.
Precisely. And a key aspect of this is the abstract process payment method.
Okay.
Think of it as a placeholder waiting for each subclass to fill in the blanks with its specific implementation.
So it's like a recipe that lists the main ingredients,
Yeah.
but leaves room for personal variations in the cooking process.
A great analogy. This is abstraction in action.
Yeah.
We define the high-level concept,
Right.
process of payment,
Right.
without getting bogged down in the nitty-gritty details of how each payment type actually handles it.
This approach keeps the core design clean and organized while allowing for future expansion. It's impressive how these principles work together.
Now let's take a look at the subclasses.
Right.
You have UPA payments, debit card payments, credit card payments, and PayPal payments.
Right.
Each of these inherits from the payment processor class,
Yeah.
inheriting its structure and behavior.
So they're all part of the payment processor family, each with its own unique personality and way of handling payments.
Exactly. And notice how each subclass provides its own specific implementation for the process payment method,
Okay.
reflecting the distinct steps involved in each payment method.
And even though they use different internal processes,
Yeah.
they all share the same method name process payment.
All right.
That's what we call polymorphism, right?
You got it. This is what allows us to treat different payment types interchangeably within the code.
Okay.
We can call process payment on any of these objects, and the system will automatically execute the correct implementation
Wow.
based on the object's type.
It's like having a universal adapter that can handle different plug types.
Yes.
Without you having to worry about voltage or pin configuration.
Exactly. And this seamless operation is one of the key benefits of polymorphism.
Yeah.
It simplifies the user experience and makes the system incredibly flexible.
This is fascinating.
Yeah.
It's amazing to see how these abstract principles manifest in the actual code.
Now, there's one more piece of the puzzle we need to examine, the
Right.
payment service class.
Right.
This is where the magic of composition comes into play.
Okay, let's take a look. So the payment service doesn't directly inherit from payment processor,
Right.
but instead holds a payment processor object as a member variable.
You're absolutely right. This highlights the has a relationship that defines composition.
Okay.
The payment service class doesn't become a payment processor itself.
Right.
It simply uses one to perform the necessary tasks.
It's like the payment service is the captain of a ship,
Yeah.
and the payment processor is the navigation system it uses to chart the course.
A perfect analogy. This arrangement allows for incredible flexibility.
Okay.
The payment service can work with any type of payment processor object,
Right.
whether it's for UPI debit card or any other method.
So the payment service is not tied to any specific payment type help.
Hmm.
It can adapt and utilize different payment processors as needed. That's remarkable.
Precisely, and you can see this flexibility in the set payment processor method. This allows us to dynamically choose which payment processor the payment service will use at runtime.
That's like having a modular system where you can swap out components effortlessly.
Exactly.
It opens up so many possibilities for customization and expansion.
Exactly. This modularity is a key advantage of composition.
Yeah.
It makes the system highly adaptable and future-proof,
Right.
as you can easily integrate new payment methods without disrupting the core architecture.
Wow, this is truly eye-opening. I'm starting to appreciate the elegance and ingenuity of this design.
It's a testament to the power of object-oriented principles.
Yeah.
Each principle contributes to the creation of a robust, flexible, and secure system.
Uh-huh.
And what's even more remarkable is that these principles can be applied to any type of software, not just payment systems.
That's incredible. So these principles are like the fundamental building blocks of good software design.
Exactly. And as we delve into the main class in the next part,
Right.
you'll see how these principles come together in action to create a seamless and efficient payment processing experience.
All right, we've journeyed through the core principles of OOD
Right.
and seen their reflections in the individual classes of your payment system.
Yeah.
Now I'm really excited to explore the main class and see how all these pieces come together in a working system.
Yeah. The main class is where we put the theory into practice. It's
Oh.
where we'll instantiate objects, set up our payment service,
Okay.
and simulate those real-world payment scenarios.
So if the previous parts were like exploring the individual ingredients,
Yeah.
this is where we get to taste the final dish.
Precisely. And the first ingredient we add is a user profile object
Okay.
for a user named John Doe.
Right.
This showcases how we securely store and manage user information.
Right, with those private fields and the
Yeah.
controlled access
Yes.
through getters and setters we talked about earlier.
Yeah,
It's like ensuring every piece of data has its own security detail.
exactly. Next, we instantiate the payment service class, our central hub for orchestrating payments.
Okay.
Remember, it's designed to work with any type of payment processor,
Right.
thanks to the power of composition.
It's like a versatile conductor who can lead any orchestra,
Yeah.
whether it's classical jazz or even rock and roll.
A fantastic analogy.
Yeah.
And to demonstrate this versatility, we create instances of different payment processor types.
Okay.
Yuki payments, debit card payments, credit card payments, and PayPal payments,
Okay.
representing the diverse methods available in your system.
So we've set the stage with our user, our payment service.
Right.
and an array of payment methods.
Yes.
What happens next?
Now comes the exciting part. We simulate actual transactions.
Okay.
We use the set payment processor method
Right.
to dynamically switch between the different payment types for each transaction.
It's like choosing the right tool for the job.
Yeah,
If you need to tighten a screw, you grab a screwdriver.
exactly.
If you need to hammer a nail, you reach for a hammer.
Right.
Each payment method has its own specific purpose and process.
Exactly. And once we've selected the appropriate payment processor, we simply call the process payment method on the payment service object,
Right.
passing in the transaction amount.
And thanks to the magic of polymorphism, the payment service knows exactly which implementation of process payment to execute
Right.
based on the type of payment processor we've chosen.
Yeah.
It's like speaking different languages fluently,
Yes.
understanding and responding appropriately in each context.
You're catching on quickly. That's the beauty of polymorphism.
Yeah.
It allows for a seamless and intuitive flow, hiding that complexity from the user, and ensuring each payment is processed correctly according to its specific method.
It's amazing to see how all these seemingly abstract principles work together harmoniously in a tangible system.
Yeah.
We have inheritance providing a structured foundation.
Right.
Polymorphism enabling flexibility, abstraction, hiding complexity.
Right.
Encapsulation safeguarding data. And composition promoting modularity.
It's like witnessing a well-choreographed dance,
Yeah.
where every move has a purpose
Right.
and contributes to a beautiful performance.
This deep dive has been an incredible journey.
It has.
I feel like I've gained a new appreciation for the art and science of software design.
I think so too.
What started as lines of code has transformed into this captivating story of structure, flexibility, and ingenuity.
And the story doesn't end here.
Right.
The world of software development is constantly evolving with new challenges and opportunities emerging every day.
All the time.
But these fundamental principles of object-oriented design will continue to serve as guiding lights,
Right.
helping us create those elegant, efficient, and impactful solutions for years to come.
Absolutely. So to our listener, we encourage you to keep exploring, keep questioning, and keep pushing the boundaries of what's possible.
Yes.
Who knows, maybe you'll be the one designing the next groundbreaking payment system or revolutionizing another industry with your creative software solutions.
And if you ever find yourself facing a complex design challenge, remember the principles we've explored today. They might just hold the key to unlocking a world of elegant and effective solutions.
That's a wrap on our deep dive into object-oriented design.
That's right.
We hope you've enjoyed the journey and gained valuable insights into the fascinating world of software design.
I hope so too.